welcome you all in this presentation related with the subject fundamentals of surface engineering. And now we are talking about the characterization of the modified surfaces which have been engineered through various techniques for improving the mechanical properties and the tribological resistance, so that they can offer the longer tribological life of the component during the service. But the tribological performance of the component is influenced by the various characteristics, which includes like the composition of the given material will be determining the kind of the metallurgical properties it will be having in terms of the phases, the grain size, structure, etc. And the metallurgical properties affect the mechanical properties of the surfaces which have been engineered, and the variation in these mechanical properties eventually will be leading to the change in the wear resistance. So this is the kind of the linkage which exists. So if you want to change or the regulate or improve the wear resistance for a particular kind of the service conditions, then we need to adjust the mechanical properties accordingly, and which can be done by regulating its metallurgical properties. And the composition in changing the metallurgical properties plays a big role, and therefore it becomes important to study both the composition of the modified surfaces, if the chemical composition modification methods have been applied, or some fusion based surface modification technique has been used where there is a possibility of change in composition, or the coating or the weld surfacing or the cladding kind of things have been applied. Then we need to see really what is exactly has been applied on the surface of the substrate, so that we can expect a particular kind of the metallurgical properties and accordingly the mechanical properties for improving the wear resistance. At the same time, for a given composition, as per the thermal and mechanical history of the modified surfaces, we may have the different kind of the metallurgical properties, which we primarily see in terms of the phases it has and the kind of the grain structure it has. So we basically try to see under the metallurgical properties phase structure and grain structure of the material. So this lecture primarily be focusing on these two aspects: how to study the composition of the modified surfaces, and how to investigate or study the metallurgical properties of the modified surfaces. So in this regard, if we see the rationale behind studying the chemical composition and the metallurgical properties of the material, so this slide shows that for a given modified surface of a particular composition, will have a set of the metallurgical properties with regard to the microstructure especially, and this microstructure will be governing the mechanical properties such as hardness, toughness, work hardening tendency, and these factors in turn will be governing its adhesive, abrasive, erosive and corrosive wear resistance. So in order to link these behaviors, we need to study the chemical composition, if the chemical composition modification methods have been applied, in where the change in chemical composition of the surface methods have been applied, or we have applied a layer of the suitable material. Layer of suitable material has been applied onto the surface of the substrate. So up to what extent the chemical composition of the modified surfaces have been realized, that is what we try to see under this stage of the studying the chemical composition. And once if it has been modified, then what kind of the phases have been obtained, and what is the grain structure of the that layer which has been modified through suitable surface modification techniques. We know that there are three broad categories of the surface modification techniques. One is where just the change in metallurgical properties is brought in without changing the chemical composition, just change in the metallurgical properties, no change in composition is brought in. And the second category of the approaches of the surface modification is where the change in chemical composition is used. So, certainly the study of the chemical composition becomes a strong case for this group of the methods. Similarly, in third category, where a layer of suitable material is deposited onto the surface of the substrate so that required improvement in properties can be achieved. So, if you have to study the chemical composition of the modified surface, say this is the substrate and its one layer has been modified through the suitable technique like just changing the surface metallurgy or changing the chemical composition or building up of a layer of the suitable material. So, as per the process, like if you are using carburizing or nitriding or boronizing, in all these cases the carbon, nitrogen or boron is introduced. So, what is the extent of the depth, what is the depth up to which these elements have been introduced, and what is their weight percentages which have been introduced to see the effectiveness of these methods. So, for this purpose we need to carry out the chemical analysis of the modified surfaces. Similarly, if we have built up a layer of the suitable material like over the surface of the mild steel, we have deposited a layer of the austenitic stainless steel. So, due to the melting of the base metal, there may be change in chemical composition of the austenitic stainless steel, which is termed as dilution. So, in order to see the extent of the dilution which has taken place due to the fusion of the base metal in the weld surfacing processes, again we need to perform the chemical analysis of the surface. So, for the two category of the processes where a layer of the material is deposited or the chemical composition is intentionally modified to enhance the properties, we need to definitely apply the chemical, we need to do the chemical analysis so that we can assess the suitability of the modified surfaces for a given application as far as the extent of improvement in the properties in terms of the mechanical properties or the tribological properties which have taken place. There are two broad aspects related with the chemical analysis. One is like macro level analysis and another is micro level analysis. So, in case when a surface which has been modified like this, so for macro level analysis we select one big area like say maybe of the 10 mm in diameter, which will be having the tens of the thousands of the grains or the micro constituents. So, average composition of that particular zone is achieved and it indicates the average composition of the modified zone. So, for this purpose one category we use one category of chemical analysis processes. So, when very large area of the modified surface is covered, like this is the area which is covered for the chemical analysis, so that it gives the better representative composition of the elements present at the modified surface. For this purpose we can use the different methods. One is the most commonly used is spectroscopy. Most commonly it is written as OES, optical emission spectroscopy. Then wet chemical analysis method. For wet chemical analysis, from this entire area we have to drill out the chips, and the large volume of the material in form of the chips is used for chemical analysis. So, you by dissolving the material to be analyzed in suitable chemicals, this kind of analysis is performed, and this gives very accurate results as far as the analysis is concerned. Then there is another kind of the spectrometer which helps in determining the carbon and sulfur concentration in especially in steel. So, that is why it is called carbon sulfur analyzer. So, this is one type of the analysis where thousands of the grains of the constituents present on the surface of the modified component are used for the analysis, and it covers the macro zone, means very large area of the modified surfaces is used for the analysis of the chemical composition. In case of the micro level, analysis is done of the micro constituents individually or over a particular zone for micro level analysis, and the kind of techniques which are used for the micro constituents chemical analysis of these micro constituents, those techniques are different. So, that is what we will see here. For macro zone analysis, when the large area is covered, we can use the wet chemical analysis, carbon sulfur analyzer, and optical emission spectroscopy, and very large area of the sample to be analyzed is used. Maybe it can vary from 5 to 10 mm, including thousands of the micro constituents present in the surface of the modified component. When it is required to perform the chemical analysis of the micro constituents individually or over a very small area, that is called like the chemical analysis of the micro zones, and for that purpose we can use the electron probe micro analyzer or energy dispersive X-ray analysis with the help of FESEM. So, when these two techniques are used, these two techniques are extensively used for the research purpose and to see the effectiveness of the surface modification. The microzone analysis using EPMA or EDX helps a lot to see the presence or distribution of elements present at the different zones at micro level. Say for an example, this is the modified zone, and we want to see that what are the elements present at near the interface, then on approaching towards the surface, how the compositional variation is taking place. Then in that case we need to select these 4 different areas, and analysis of each area is to be performed, and this area may be very small, like 100 square micrometer square. So, very small area is analyzed for this purpose. We can select even very point also, it does not have very large area, and this point may be of the diameter of 1 micrometer or 2 micrometers, like that. So, there are various techniques for performing the microzone analysis using EPMA or EDAX, and these techniques are these are the 4 techniques which are used for microzone analysis. One is called point analysis, another is area analysis, third is line analysis, and fourth is elemental analysis. And each one now we can will try to understand. Like say this is the area which is under focus at a magnification of say 200x. So, we are able to see various micro constituents under the scanning electron microscope. So, these EPMA or EDX both are used in combination with the scanning electron microscope, and we select the suitable magnification so that the micro constituents are very clear. If these are various constituents which are present in the microstructures like say A, B, C, DA like this we can go for marking. Different micro constituents are present. So, if you want to see how the compositional variation is taking place within the grain or changing going from one grain to another, then we can use this kind of these various approaches of the micro zone analysis. Like say if the analysis of particular small zone is to be carried out, then we select that particular point and it is analyzed. This may be of just of like say a small area of 1 micrometer or 2 micrometer in diameter. So, in point analysis we select the point which is to be analyzed. It may be grain boundary or it may be a particular micro constituents which is of a smaller size. So, for point analysis we select the point on that particular micro constituent which is to be analyzed, and that will be giving us the result about the kind of elements which are present at that particular point. For area analysis we select the larger area as compared to the point for the purpose of analysis. So, in that case one area like this is selected and it is analyzed. This area may be at the center of the grain boundary, or it may be within the grain or close to the grain boundary. So, that area is chosen as per our interest which area is to be analyzed. For example, in the surface modification, when we have developed one flame spread coating, and this is the substrate or the base metal, and this is the coating which has been developed, and we expect that there is a segregation or localization of some of the elements near the interface. So, now we can select this area and it can be analyzed. If you want to see how the concentration of particular element is varying from the interface to the surface of coating, then we select these 2 points, and then scanning is performed all along this line to see how the compositional variation along that particular line is taking place. So, for that purpose we have to carry out the line analysis. So, line analysis helps us to see how the concentration how the distribution of the element is changing between the two selected points of our interest. Say this is one grain and this is another grain, and if we are interested the way by which the distribution of the element is changing from the one center of the one grain to another, then we can choose these 2 points. 2 points are connected through a line, and say this distance is of the 100 micrometer. Then time interval between between these 2 points means the spacing of for the other points between these 2 points along a particular line can be selected. For if you want to perform the analysis at 20 points between these 2 points which are located at 100 micrometer distance, then the 20 different points will be analyzed by the EDX or EPMA at the interval of the 5 micrometer. And if you want just to see that analysis of the selected points is carried out, then we can simply carry out the point analysis. And if you want to see the line scan, or if you want to see the continuous variation in the concentration of the elements between any 2 points, then we have to perform the line analysis. The last one is the elemental mapping. Elemental mapping helps us to see where which element is present in selected microstructure. Say if according to this schematic diagram of the microstructure, if you see A, B, A, these are the same types of the micro constituents. Similarly, here A, C, these are made of the different micro constituents. These are the different phases, so they will be made of the different micro constituents. So, if the mapping is carried out, elemental mapping is carried out for this entire area, say mapping for the A is carried out first, then A will be giving us all these grains where A is present. These areas will be bright. Like if the mapping for A is being done, then wherever A is present, it will be showing the higher concentration of the A, and these areas will be bright. Rest of the areas where A is absent, that will be shown as a dark field. Similarly, when the B is analyzed, when analysis for the B element is done, then what we will see that the certain zones where B is present, they will be bright, while other locations will be dark. So, this is the location where B is present. So, these fields will be bright. The elemental mappings gives the areas, zones where particular element is present. So, it helps to map the presence of particular element in given microstructure. So, whether we are carrying out the microzone analysis or the micro zone analysis, in both these kind of analysis help us in understanding or in confirming the composition of the modification, confirmation of the modification. Say if we have carried out the carburizing, then carburizing is carried out to increase the carbon content from the 0.2 to 0.8 or 1% of the carbon content, and whether and this we can confirm through the chemical analysis if the carbon content has been increased to the 0.8 or 1% level or not. So, after the surface modification, if the required chemical composition has been achieved or not, that is what we confirm through the chemical analysis. So, confirmation of the chemical composition modification for the second group of the approaches where we use carburizing, nitriding or boronizing. So, we can analyze to see whether the boron is present in the required amount or not, or the nitrogen is present in the required amount or not, so that it will be forming the different phases, compounds for improving the properties. Then the quantification of the dilution, it also helps to analyze if we have added like 12% of the chromium, but actually in the weld surfacing it is just 7%. So, this reduction is attributed to the dilution. Similarly, we can see whether any kind of the segregation or the loss of the allying elements or the depletion of the allying element is taking place, especially near the coating substrate interface or any other zone of the modified surfaces. So, it helps us to see the distribution of the elements in the modified zone, and the components which are subjected to the adhesive wear. We know that a typical mechanical mixed layer near the surface is formed, which will be having the elements from the counter surface as well. So, what is the depth up to which this kind of the modification, chemical composition modification has taken place, and what are the different elements present in the modified zone, that is the mechanical mixed layer. What are the different elements present in mechanical mixed layer, that is what can be analyzed through the micro analysis of the worn out components. So, these are the 3 or 4 purposes of the chemical analysis with regard to the surface engineering. This is just an example of the line scan analysis. Like say this is the nickel tungsten carbide coating deposited by the flame spraying method, and this coating is having primarily tungsten carbide, and the dark one is the eutectic matrix. So, here the analysis performed between these 2 points, like say the point A and point B. So, considering this point A is here and point B is here, and what we see that when the scanning is performed, as the line scanning is done along this white bright particle, there is a huge increase in the concentration of the tungsten, which is suggesting that these white particles are enriched with the tungsten, since in this coating tungsten carbide particles were used. So, the EPMA confirmed that these bright particles are polyhedral shaped bright particles are of the tungsten carbide particles. Similarly, here we can also do the line scan. In this case, this is the substrate and this is the coating substrate bond interface, and this is the coating. So we can see here at the interface, near the interface, the concentration of these carbide particles is less, and if we see there is a dark band. So this is this kind of the band is formed due to the segregation of the carbon near the coating substrate interface, and this zone may be hard, and once if the heat treatment is performed, sometimes this zone is eliminated by the diffusion of the carbon into the coating and into the substrate. So basically EPMA line analysis helps us to see the distribution of the different elements along a particular line. Here also we can perform this kind of analysis, starting from substrate to the coating. We can perform the line scan along this particular line. It will be showing the variation in the elements that we want to analyze, and this kind of analysis can be performed for the different elements as per our choice. For example, in this case the analysis between these 2 points was carried out for nickel, tungsten, cobalt, chromium, silicon. So analysis elements for analysis are chosen in such a way that they are present in that particular material or in that particular coating. Similarly, this is an indicative of the area analysis. For area analysis, this is the area which was selected and it was analyzed. This is showing the diffraction pattern achieved through the EDX analysis. I was talking about the elemental mapping, like say this is the microstructure of the hard facing coating, where the matrix is of the eutectic, and it is having the carbide particles like chromium carbide particles. So wherever chromium carbide particles are present like this, when the elemental mapping is carried out for chromium, we will see the bright particles in the zone where chromium is present, and other locations and when the analysis is done for the other, since this was the iron based iron chromium carbide weld surfacing. So in this case the matrix primarily is comprising the iron wherever the bright particles are present, and these chromium carbide particles where chromium was dominating, iron is deficient. So we are getting the dark one, while the manganese is almost dark, or you can say that the manganese is well distributed in the entire zone. Similarly, this is the elemental mapping for the another kind of the fracture surface, which is showing where the silicon is present, where aluminum is present, where carbon is present, sodium potassium is present, and calcium is present. So elemental mapping helps us to see for a given microstructure, it helps us to see where which element is present. Now another important aspect is the microstructure, and microstructure study we can carry out using the optical microscope or scanning electron microscope. So for the low magnification or for less resolution purposes, maybe we can carry out even the optical microscopy, otherwise it is performed using the electron microscopy or scanning electron microscopy. But microstructures simply be indicating the different micro constituents which are present. They do not confirm which phase it is. It will be just showing the different shades, colors, different sizes, and different shapes and their distribution. These are the three things. It does not confirm which type of the phase particular thing is. So for confirmation of phase, we need to carry out the X-ray diffraction analysis. So there are two broader aspects as far as the microstructure analysis is concerned. One is the grain structure study, wherein we have to see the grain size, shape of the grains, and the distribution of grains, means where which size and shape of the grain is present from the interface to the surface of the modified coating. Similarly, under the phase structure, we try to see what are the different types of the phases are present in the modified zone, and then their relative amounts and how they are distributed. Like for the nitriding, there may be iron nitride formation. In case of the carburizing, it may be martensite, and martensite may be more at the surface and less at the interface or near the base metal. Similarly, the grain size and shapes may also vary from the surface to the interface of the modified zone. So, for analyzing the different sizes, shapes and their distribution, as well as proportioning of the various phases and identification of the and their distribution, the image analysis is carried out. So, for the image analysis of the microstructures, image analyzing softwares are used. ImageJ is one typical software which is available in public domain for the analysis purpose, and this is the one which also can be used for the image analysis purpose, so that microstructural analysis can be performed. As far as the characterization, metallurgical characterization is concerned, we will take up the example of the weld surfacing. So, here the weld hard facing is on the mild steel substrate is carried out, and we took the sample from this zone, and it analysis was performed. So, here both sides we have the substrate of the mild steel, and in between there is a weld surfacing deposit. So, what it shows that at the interface of the base metal there is all these are the columnar dendritic grains. So, primarily it shows the fine columnar dendritic structure in the weld surfacing of iron chromium carbon system. At the interface it is sound, there is no crack, there is no porosity. So, the good bonding at the interface, plus it is coupled with the kind of the columnar dendritic structures. Now, it can be used like, since this is dendritic structure, so we can see the interdendritic arm spacing for sizing, since and this is the columnar dendritic structure, spacing can be used. Here we can see some kind of the planar structure also is visible just at the interface, but thereafter it is primarily the columnar dendritic structure. So, now here I will summarize this presentation. In this presentation, basically I have talked about the need of the performing chemical analysis and the various techniques which are used for performing the chemical analysis of the modified surfaces, and what are the different features that we try to look into the microstructural aspects of the modified surfaces. Thank you for your attention.